We'll proceed in summation to integral calculus. Summation to integral calculus, mind-blowing discussion that we are proceeding upon. Summation to integral calculus. How I can divide problem into n different parts and solve it part by part and then finally sum it. Okay, when we sum all the n part and still we believe that solution is not accurate, it would have been accurate had it been n equal to infinite. So in that case, we change the summation from we the number n what we are using now, the number n what we are using now, n tends to infinity. If I have a summation that is for n part and n tends to infinity, then it will change into integral calculus. I mean, any summation where summation of n parts where n tends to infinity, summation can be replaced into integral calculus. There is no guarantee warranty that directly we can change it to integral calculus. For that, there is no guarantee. But integral calculus is the integral calculus is the what I'm trying to say is that if I say like summation I equal to 1 to n, then I have function over x, and then n tends to infinity, then I cannot rewrite as fx dx and then x is from one location to another location. But yes, if n tends to infinity, then it is a potential candidate to transform into integral calculus. If n does not tend to infinity, then no. It must converge. N tend to infinity means it must converge. What is convergence? Okay, convergence means suppose I want 1 plus 1 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus up to n, where n tends to infinity. What it is? Doesn't make any sense. Infinity. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus n. Now tell me what it is. Okay, someone can tell what it is. If n tends to infinity, then infinity. This is not converging. It should converge in the sense that it should become it will tends to zero. Convergence means it should become tends to zero. What is tends to zero? Like 1 plus 1 by 2 plus 1 by 3. I mean 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by n, where n tends to infinity. Now it makes sense. Because if n tends to infinity, last term will be 0. In that sense, we can have the addition. So these all falls in repeated summation. Okay, how we can calculate repeated summation? Someone can use his IQ level. After this, we'll talk about differential calculus post this summation. So someone can use his IQ like S equal to, I believe S equal to 1 plus 1 by 2 plus 1 by 4 plus, it is 1 by 2 to the power I, where I starts from 0. So 1 plus 1 by 2 plus 1 by 4 plus 1 by something like that. What is it? Is summation S equal to 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16. I believe so. It is like that. Okay, then someone can multiply it by 1 by 2. Multiply it by 1 by 2. Now it is S into 1 by 2 equal to 1 by 2 plus 1 by 4 plus 1 by 8 like that. So S minus S by 2 equal to 1. Equal to 1. Someone can find what is S. He can use his IQ. But concept arising is, can we use integral calculus to find the net sum? That we will see. Anyway, right now we are in mood to discuss about the implication of vector. Introducing vector to calculate the any solving any problem. Why I need to introduce vector? Where it hits in. So those things we are in the mid of talking it. Vector. If vector, okay, how I solve the any problem? I divide problem into n different parts. I divide problem into n different parts. Each part Each part I can address is as a fxi. What is fxi? Okay, so what is fxi and those kind of things? Like we have started a discussion how to find circumference of a circle. How to find circumference of a circle. This is x-axis and this is y-axis. This is x-axis. This is y-axis. Now I chop this x-axis into n different parts. Make sense? And then each part has this circle has a radius of a. A is the radius of the circle. Means from origin, this is A and this is minus A. If I chop into n different parts, then this width is 2A. Each part has a width of 2A by n. 2A by n. Okay. Now in that fashion, now if I take this part, consider this is the first part, second part, third part, fourth part, fifth part, ith part, like that. Consider this is ith part. If this is ith part, it goes up and hit 2 points on this circumference. What is the length of this circumference? Provided that it belongs to ith part. Consider this is origin. First point is x. The next point is x plus 2a by n. This is the ith section. Ith section. Okay, what is the length of this ith section? Ith section means yeah, ith section means from up. I have taken from this side. Okay, consider that I am taking the ith section. Hope mixing so many things. Consider I am taking ith section from origin only. First section, second section, ith for time being now. Ith section. If it is ith section, then what is this x? What is this another x? This x is 2a by n into I. 2a by n into I plus 1. Or if this is x, then the next one is x plus 2a by n plus x whatsoever. Now, if I go up, then it hits 2 points. What is the circumference of this region when it is connected from a ith section on x-axis? If I know, I can call it pi, perimeter of the ith section. Perimeter of the ith section. Now I can write as summation I equal to 1. Summation I equal to 1 to n. Perimeter of the ith section. If I add all the perimeter of all the sections, if I have taken like this, it will make sections. If I add all the sections, it will give half of the parameter. If I multiply by 2, I can get full parameter. Someone would say you would have divided this into n equal part like this. That we have already done. Now we are in phase of vector. That's why we are doing like this. Now if I take vector form, then if I talk about the ith section, it goes up and hits here 2 points. Consider this point is x1, y1. This point is x2, y2. Then there is a vector called p vector, p1 vector. And this is p2 vector. p1 vector, p2 vector. Delta p vector. p1 minus p2 will be a vector, or p2 minus p1 will be a vector that is connecting x1, y1 and x2, y2. Okay, if I find the length of this delta p vector, or p1 minus p2, it will give this much length. This much length is this much length. Okay, if I have divided into n part, then like this, all length in a straight line I get. Okay, I can rewrite this as summation I equal to 1 to n delta p of the ith section. What is delta p of the ith section? Then someone calculate, but certainly it is not the accurate solution, because delta p length will be a straight line length, whereas we want the curve length. In that fashion, we will say n tends to infinity. If n tends to infinity, then we chop into infinity part, so that if I map one section, it will be so small, it will be so small that curve will be like a straight line. Then it will be accurate. This is one way that we have already discussed. Now we are going to have the more accurate way in vector, where we don't need to estimate anything. Then we are going with a concept of tangent. What is tangent? Tangent is nothing but, consider this is a curved line. If this is a curved line, then at this point, what is the tangent? Oh, I know. Tangent, if you take one point here, then tangent will be exactly a line touching that point. What is tangent here? This is tangent here. This is, oh, this fundamental will not work. What actually the tangent is? Okay, tell me. If this is a straight line, then what is tangent at this point? At this point, there will be a line touching this point. If I draw like that, it will hit the full line only. That is the tangent. So to a straight line linear equation, the tangent equation is same as the straight line only. But for a curve, tangent will be a line that will touch the curve. What is touching the curve? In past video we have talked about it. Tangent is nothing but a line which talks about direction of the curved line at that point. Curved line is varying direction. It's not a straight line direction. If there is a straight line, then direction of the straight line is always same. What is direction? If this is x-axis, then at every moment if I take y by x, that is the tangent of the angle it makes. Y by x, that is nothing but tan theta. Everywhere tan theta equal to y by x will be same. Everywhere y by x will be same. Means theta, theta correspond to all point on this line with x-axis will be same. Okay, but if it is a curved line, then if I start taking from here and this is x-axis, then at this moment if I take this line is making a round. At this moment, if I take the orientation of the line, I'm not talking about the tangent. What is the direction in which the line is going on at this point? At this point, then if I go inside it, then I'll take a very small section here, so small that it will be a straight line. This is also called linear localization. Means you see from so small that it should look like a straight line. The way we see Earth as a flat only, though it is a pure round. Earth is like this only. But we are so small like ant that we see the Earth like a flat. But we see moon as a round way because we see from the distance. So if I see it from the local linearity, very small distance, it should feel like a straight line. In that manner, what is the direction of that straight line at particular point? That is the tangent. At any point on this curve, if I check that line that is passing that point, if I draw one point, consider I put a point here x comma y, then this line is passing x comma y. The moment it is passing x comma y, what is the direction of that line at that moment? At a point x comma y, if line is passing, the line is curved. But at any point when line is passing, it will be a particular direction at that moment. Moment by moment, direction is changing. That at that moment, what is the direction of the line? That direction, if I put in a straight line, that is a tangent. Tangent talk about the direction of the line at a particular point. Tangent, I cannot say tangent of this line is this. At what point? No, tangent is this. Means I am considering it is a straight line. If it is a curved line, that every moment line direction is different. At a particular moment, what is the line direction? That is the tangent at that point. That is the line direction at that point. Okay, if I did, then we saw that how to calculate line direction. If I want to calculate line direction at this point, it will be tangent. What is tangent? To calculate the line direction, we'll take a small section here. If I take a small section here, then it has two components. One is horizontal component, one is vertical component. Horizontal component, vertical component. Vertical component by horizontal component will give the tangent angle tan theta. If I know the line direction at this point, this is x comma y point. This is x axis, this is y axis. This point is x comma y. If this point is x comma y, at that moment line has a direction. If it has a direction, means at that moment I can describe that line direction as a straight line. This straight line forms an angle with the x-axis. If that angle is theta, then tan theta is how much? Tan theta is how much? Then tan theta is, if this particular point I am trying to find the direction of the line, at this point around this point, I take a small section so that I can consider it as a straight line. Okay, or if this was the point and I thought this is a tangent line, then I take, then what is delta x and what is delta y? I mean, at this point I take a small section and I take out this small section and see this section. If I go on the x-axis, what is the interception? I go on the y-axis, what is the interception? I consider the interception on y-axis is delta y. Interception on x-axis is delta x. Then what is delta y by delta x? That is the tan theta it forms. That is angle of the tangent. Delta y by delta x. If delta x tends to 0, then it is dy by dx as the first principle of the differentiation. This is dy by, no, how I can consider this is dy by, this is division. Okay, there is difference between division and differentiation. Division talks about what is the net amount by the net amount. That is division. I have given example many times. What is division? Okay, like if I have two bags. Again, I am taking that example. I have two bags. In one bag I have orange and one bag I have tamarind. Tamarind. At one moment, the orange in orange box is two. Then tamarind I am seeing it as four. It is 4. After some time, I see in orange bag, orange count is 10. Then I see in tamarind bag, it is 20. Now I'm asking, tell me, how many tamarind per orange? Then 20 by 10, 4 by 2, 2. 2 tamarind per orange. This is one thing. Another thing, it tell me how many tamarind, how many tamarind in changing if I make one change in orange. How many tamarind per orange? Each orange corresponds to 2 tamarind. That is one. That is separate thing. Now tell me, if I make 1 unit of change in orange at any moment, how many unit of change I see in tamarind? What do you mean? I mean that at when I have 10 oranges, if I add one orange, then how many I need to add in the tamarind bag so that equation will be same. Then if you add one, then you have to add here two because it is two per orange, two tamarind. So per orange change is also two is there. Okay. Now consider that it is now orange is two, then tamarind is four. Orange is 6, then tamarind is 36. Orange is 10, then tamarind is 100. Now tell me how much tamarind per orange? Oh, 10 by 10 by 100 by 10, 10, then 36. Oh, it is not constant. Looks like it is a square relationship. It with x, then it is x square. Then how many tamarind per orange? X square by x. X. How many tamarind per orange? It is x. Okay, it is x. X, how many tamarind per orange means it is x multiplied by whatsoever. If it is how many tamarind per orange? For one orange, how many tamarind? X. If it is x, then it is x square. Okay, something like that. Now tell me, if I at any moment, if I add how many change, how if there is one thing, that is how many tamarind per orange. That is one statement. That is division. If how many tamarind would change if I make 1 unit change in orange? Change is different than how many they are in division. So at any moment, consider orange is 6. At that time, if I add one orange, this is 1 unit change in the orange. It brings how many unit of change in the tamarind? Then x squared by x. Not true. Division will not give the answer. No. Now we need differentiation. Okay, so if I say y by x, then it is division. That is tamarind by orange. But if I see delta y by delta x, means how many change in tamarind I see when there is 1 unit change in orange. Delta y by delta x, both are different. Okay, so delta y by delta x is represented through differentiation, not through division. So now here we have to find the tangent angle tan theta. If there is a line at this point has a direction like this, then this direction will form theta degree with x axis. Tangent of this theta, tan theta, will give vertical by horizontal. That vertical is not y by x. This is what I'm saying. That is not the division. If this is the point and this is x-axis, then I'll say this is the y and this is the x. Consider this is origin for time. Or if this is the origin, consider this point. Then I say this is y and this is x. Y by x. Y by x is the tan theta at that point. So that is the angle of the tangent at that point, but that is not true. Okay, if I want to find that line direction at any point x comma y, line direction, what is direction? If I have a line, it go and hit the x-axis. If it makes angle theta, then what is tan theta? That is direction. Okay, so if I say what is direction at any point x comma y, then I cannot say it is y by x. Not true. Difference in x brings how much difference in y? Delta y by delta x. That is the direction of the line at that point. That is dy by dx, not y by x. Y by x will be completely different. Okay, understood. Now I learned that how to find tangent line. Any line I can write equation as y equal to mx, where m is the slope of the line. So it looks like that every moment the tangent line is different. Okay, but how I can address? There will be infinite tangent lines. Then you can address it as you have to bring tangent in the form of algebra. If someone brings the tangent in form of algebra, then it can be represented through the single equation, that is y equal to mx, where m is the slope. Slope means tangent of the theta. Then it is dy by dx. Y equal to dy by dx into x will give the equation of the line. Yes, if I have a sinusoidal wave, then I know dy by dx of sinusoidal is cos x. That then what is the equation of the tangent line? Y equal to cos x into x. Okay, where cos x at what point you want? I want at x equal to, this is x axis, and then it is sinusoidal wave like this. Okay, at this is, there is a sinusoidal wave like this. This is a sinusoidal wave like this. Now, what is the tangent if this is the sinusoidal and this is 180 degree? Then what is the tangent at pi by 2? This is x-axis, this is pi by 2, this is pi. What is tangent at pi by 2? Can you tell me the equation of tangent at pi by 2? Yeah, I can tell the equation of tangent. That is y equal to mx. But you said m is dy by dx, that is cos x. Yeah, cos 90 degree. Cos 90 degree is 0. Y equal to 0. Yeah, that is the tangent. Oh, what is y equal to 0? Y equal to 0 means there is a line that is parallel to x-axis. Okay, if y equal to 0 is hitting the y at 1, hitting at y at 1, then the equation will be, I believe, y equal to mx plus interception on the y-axis. That is 1. So y equal to mx plus 1. I think so. Okay, y equal to mx plus 1 or something like that. Someone can try. Y equal to mx will give the actual line. Let's try. If it is x equal to 0, then x equal to 0, then cos x will be 1. So y equal to cos x into x. X is 0. X is 0. If x is 0, then cos x is the dy by dx. That is 1. So y will be 0. 0 plus 1. Y equal to 1. It will be y equal to 1. Y equal to 1. No, but that is not true. Y equal to, oh, y equal to 1. Y equal to 0. Okay. Okay. So when x equal to 0, the tangent line, when x equal to 0, at that moment, the the tangent line has slope of 1. The slope of 1. Y equal to mx. Y equal to x. Okay, I'm not setting x as 0 right now. Y equal to x. That will be the equation applying at that point. Since it is passing origin, it will be y equal to x only. Means it will make 45-degree angle. When sinusoidal is going, tangent at 0 location will make 45 degree. Y equal to dy by dx is 1 when x equal to 0. When x equal to pi by 2, then equation of the line will be now a rephrase. Then equation of the line will be y equal to 0x, then y equal to 0. Okay, and then it is cutting x axis, y axis at 1, y equal to 1. At that moment, the line equation will be. These are the tangent form. Now, can we derive the vector form from the tangent line? Now, I know what is the equation of tangent line. Tangent line, if I know, if I try to find the equation of the tangent line, then it is y equal to dy by dx into x. Okay, that dy by d. What is the equation of tangent line at any point here? Then calculate dy by dx, and then write a line y equal to dy by dx into x, where x is independent component, y is dependent component. Dy by dx at a certain point, that will be a numeric number. Right now it will be algebraic, but someone has to convert it to numeric depending upon point to point. What is y? X square plus y square equal to a square. What is y? That is the square root of a square minus x square. Dy by dx will be minus x by square root of a square minus x square. That is dy by dx. Now someone set the x where he wants the slope. If x equal to 0, then slope will be 0. Means if it is origin, then up here the slope will be 0. Y equal to 0 will be the equation of the line, or wherever it hit, you have to add that option. Okay, what about x equal to a? Then slope is like this, right? Substitute dy by dx equal to minus x by square root of a square minus x square. X is a. A is 0, infinite. Y equal to infinite into x, that is the equation of line. Infinite slope means angle is 90 degree. Exactly like this. Okay. Now next question arrives is how I can represent. Now I know how to calculate tangent of a curve. To get the tangent of a curve, that is delta y by delta x dy by dx, that is the slope. Y equal to dy by dx into x, the equation of the tangent. Okay, wherever if it hits x or y, that someone has to settle it down. Okay, thank you very much. What will be the vector equation of this line? How I can convert a line into vector equation? Consider this is x-axis and there is a point x comma y. What is the position vector of this? Then x, this is 0. Then x minus 0 I plus y minus 0 j, xi plus yj. Okay, now I have a line like this, that is a tangent line. Y equal to dy by dx into x. Now tell me what is vector representation of that line. Now let's watch it minutely now. What is dy by dx? Per unit, one unit means 1. Per unit change in x brings how many unit of change in y? Okay, per unit change in x brings how many unit change in y? Means if I have a function, if I have a function like this is x-axis, and there is a function like this. If I take x here, then y is this much. If I move 1 unit, then y is this much. If I see, then there is a difference in y vertical is this much because of 1 unit change. Then dy by dx is this much because y by x, delta y by delta x deliberately I have taken 1 only. Delta y by delta x is the derivative. Means for 1 unit in x, I have how many unit in y? That is dy by dx. If I have 2 points, one point is x comma x1 comma y1 and another point is x2 comma y2, then what is the equation of the vector? X2 minus x1 plus y2 minus y1j, that is the equation of vector. Now tell me, if I have origin and I have 1 unit length here and another is dy by dx, because per unit the height is dy by dx, makes sense. If I move from one location to another location and that is 1 unit, then how much y is changed? Dy by dx, that is the y change. That is delta y by delta x. That is the change per unit. Means if I move delta x, then how much is the delta y? Then it is delta y by delta x. Then it is delta y. I believe I'll make it more clear. If there is a point x here and I move delta x, because of delta x movement, how much y is moved? Delta y. Then I say with delta x movement, how much movement I see in the vertical delta y movement. If it is delta x along x axis, then in vertical it is delta y. If it is 1 along x axis, then delta y by delta x. Means if I have origin and if I move 1 unit, then how much unit I move in the vertical? Delta y by delta x. Means I have 2 points. Now, one point is origin and another point is 1 comma delta dy by dx. This point is I, this point is 1 comma dy by dx. What do you mean? I'm talking about tangent line, representing a tangent line with a vector. And tangent line is y equal to dy by dx into x. If I interpreted this tangent line in a graphical manner, then if it is 1, then height is dy by dx, because tangent line is a straight line. If it is 1, then it is dy by dx. Now, if I try to represent in a vector, then this is origin and this point is 1 comma dy by dx. Then what will be the vector? That will be I plus dy by dxj. What do you mean? I mean it means if I have any position vector, if I have any position vector to point x comma y and origin, this is the position vector. If I talk about this x comma y on any graph x comma y, then if I talk about the tangent line equation, then it will be y equal to dy by dx at this point. This point is x. If it is x1 comma y1, then y equal to dy by dx at x equal to x1, because y is anyway it is a function of x1. What is the equation of tangent line at a point that is x1 comma y1? This is x-axis, this is origin. x1 comma y1. The equation of the tangent line at x1 comma y1 is y equal to dy by dx at x equal to x1 into x. What is dy by dx at x equal to x1? What is dy by dx for the circle? Minus x by square root of a square minus x square. Substitute x as x1. Dy by dx at x equal to x1 is minus x1 by square root of a square minus x1 whole square. Okay, in that fashion, what is the equation of the line tangent line at point x1 comma y1? The equation of the tangent line is y equal to minus x1 by square root of a square minus x1 whole square into x, where x is the independent variable component and y is dependent, and this is the slope. Okay, in generic manner, it will be y equal to dy by dx at x equal to whatever we want into x. Keep changing dy by dx at different point, you keep getting different tangent line. Okay, if that is the case, then this is a generic line equation, y equal to dy by dx into x. Then what is the generic equation of vector representation of this line? Then this line, what we are talking about, a tangent line, that is a straight line. It is passing through a point that is 1 comma dy by dx. If any line that is passing through a point 1 comma dy by dx and another is origin, then that can be represented, that line, in a vector as I plus dy by dxj. What do you mean? I mean it. Means if this is x comma y and this is origin and this is the position vector, then tangent at that position vector, if I try to get at this point, if I have any point x comma y, then position vector is xi plus yj. If it is x comma y, then tangent vector is I plus dy by dxj. Makes sense? Oh. It looks like the tangent at any point is derivative of position vector 1. Position vector is xi plus yj, then d of position vector by dx is I plus dy by dxj. Okay, what do you mean? If I take any curve, that was a circular curve I took. If I take any curve, this kind of proof is not available in any of the book. How you prove that derivative of a vector is the tangent at that point? Can someone prove it? Okay, this is x-axis. If this is x-axis, consider there is a line like this, y equal to x square. What about that? What about the vector representation of a tangent at this point called x comma y? That is I plus dy by dx j. What is the position vector at this point? Then from origin I connect this line point, that is the position vector, that is xi plus yj. If I do dp position vector p on top of it, mark make a arrow mark p on top of it, an arrow mark p equal to xi plus yj, dp by dx equal to I plus dy by dxj. That is same as the vector representation of tangent line. Mean tangent line at any point is tangent at any point is dy by dx. I'm sorry, dp by dx. Okay, thank you very much. Means dp by dx is I plus dy by dxj. Now, if I talk about the energy concept, then this vector has two energy components. One energy component is x-axis energy component. Means there are two energy. They are combining and making another energy, that is I plus dy by dxj. Means if I consider this as origin, then one energy is coming toward the origin, going toward x-axis, and it has a strength of 1. Another energy that is coming from negative of y-axis passing through origin and going toward the y-axis, and its strength is dy by dx. If they mix together, they will make another energy, that is I plus dy by dxj. It has two components. Horizontal component is 1 and vertical component is dy by dx. Okay, thank you very much. Now tell me what you want. Now I am saying that if I have at any point I have a vector, that vector represents the line. Vector is a vector, that is tangential vector. It represents a line at that moment. If I calculate magnitude of that vector, momentarily I can calculate the length of that line section at that moment. If I have, if this is x-axis and this is origin and this point is x comma y, what is vector? xi plus yj. If I calculate magnitude of this, then magnitude of vector, then x square plus y square square root, that is exactly the line length from origin to this. If any moment, if I have a vector that is I plus dy by dxj, if I calculate magnitude of this vector, that vector represents the tangential vector at any point. That they will touch that point at that moment. At that moment, what is the length of this section? Then magnitude of the vector. That is square root of 1 plus dy by dx whole square. Okay, looks like we are moving towards something. What is the main concept we are trying now? The main concept we are trying is, if this is a circle and this is x-axis, we chop this x-axis into n different parts. If there is one part here, ith part with width is 2a by n. If I go up, then what is the length of this part? This is the length of the ith section. What is length of full circumference? Summation I equal to 1 to n, length of the ith section. How I can use vector to find the length of the ith section? In that section, if I take any point, then I can represent it as I plus dy by dxj, length of a vector, tangential vector at any point. If I take this section, then there will be many tangential vectors in this section also. If I take any tangential vector, and momentarily the length will be the magnitude of the tangential vector, that is I plus dy by dxj, that is 1 square I is 1 square plus dy by dx whole square root. If I know the momentarily length of this, then can I calculate the ith section length? If I know the ith section length perfectly, I can sum it for n times. Then repeated summation would give the exact length of this. We'll proceed on this because I'm really sweating. So this is the way that vector can be used to calculate the exact length. Not that, okay, let's approximate this, tends to 0 and nothing. It is exact. Momentarily, any moment, what is the tangent vector? If I know tangent vector, if I calculate the magnitude of tangent vector momentarily, it will give the length. Then you can generalize it for bigger area and you get it. We will see. Please do not mind supporting us or mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.